Hi guys, welcome to Programming Conditionals. In the previous lesson, we explored the concept that things were done in sequence. So when you ran a program, it would do the first thing, then the second line, and the third line, all in order. Now, that works pretty fine for some programs, and for some situations that's fine. However, sometimes what we want to do is have a concept called branching. So you have a path of your code, this is represented by a line here, and suddenly you need to make a decision. Let's say you're coming up to traffic lights. Now, the way traffic lights work is that they sense whether they either use a camera to see whether there's traffic there, or they have a weight sensor to sense whether there's a car there. And if there is, then you can either go one way and it could go green lights, or go another way and stay as red, for instance. And then you can have other versions depending on conditions of other lights and other cars there. And really, this ability to go in more than one direction is absolutely crucial. So to recap, programming first concept is sequence. Things are done in order. An algorithm is a sequence of instructions to achieve a goal. However, if you just do things in order, that means you will do the same thing in the same order every time. Sometimes you don't want that. Sometimes you want to choose to do one set of instructions or another set of instructions. That is called selection. And that is what we'll explore right now. We will look at selection, how we can make use of it, and how it can make our programs way more powerful. Probably the most powerful thing in programming is selection. So the statement we'll use, or the condition we'll use here, is something called an if statement. An if statement says basically, if this is true, then do this set of instructions. If it's not true, do this set of instructions. That's going to allow you to branch in two directions. Let's have a little read of actually what we've been asked to do. In our sequence of, in our little problem here, it says, write an algorithm that requests for a user their height. So straight away, hopefully you're thinking, okay, we're going to need a variable to store the person's height. We're going to have to output to the user that they need to input a value, and we're going to need that person to be able to input their value in. So far, nothing new. But then we say this: if they are 120 centimeters or taller, they can ride Hyperspace Mountain. And I guess if they're not over 120 or higher, they can't. So how do we do this? Well, let's start off by asking the question, the output. So the question will be a bit blunt, but I think we'll just ask, how tall are you? So how tall are you? And I suppose what we should mention is that this is in centimeters. Remember, this is a conversation between the system and the user. The system's prompting the user by asking the question. Then the user's going to input their value, and we need to store it in a variable. Let's think of a sensible name. Sensible name, I think, would just be height. So height is the variable we're going to create, we're going to declare. Arrow pointing towards it because we're going to assign it a new value, and then the command will be a user input will allow us to store a value in there. And now we have to do one of two things. Either the person is 120 centimeters or higher, in which case they can ride Space Mountain, or they can't. And here's how we do that. We write if, so that's a command, and I'm doing it in capitals like that. Well, if what? Well, if height is greater than 120, then, and we can do output. Notice how I indent. I'm writing it slightly inside it. That's a really good programming convention that you want to adopt, because it will make it easier to follow code. Output, you can ride Space Mountain. I suppose it's Hyperspace Mountain, but If you forgive me, this means I can, well, I said space mount. This means I can do it on one page, if you can forgive me, or one line, I should say. And then I can say maybe else. So what happens if you're not? Now this time I don't have to do a test. I'm literally saying everything that isn't true in the first case. So if you're not bigger than 120, then you're anything smaller. I guess that means as small as 0 centimeters, but that's not realistic. And I can say, oh, shall we be brutal? This is going to be a bit mean. Bit of a mean message. Sorry, shorty. For any of you who are shorter than 120 centimeters, apologies. We are all short once. Anyway, this. Oh, and then we have to end if. Now let's follow this bit of code for a second, because I've actually deliberately left in an error. So let's follow this code. Output, how tall are you in centimeters? The system outputs that to the user. The user responds and stores their value in height. We test the height. We say, is it greater than 120? Then output, you can write space mountain, works. Else output, sorry, shorty. Again, sorry for the brutal message. But let's read here for a second. If we read here for a second, it says if they are 120 centimeters or taller. If you look on this bit of code, if I type in 120 for height, 120 is not bigger than 120, so it'd say I'm actually too short. So we need to tweak this to say not just greater than, but greater than or equal to. And then it will work just fine for us. That would be called a logic error, because the program would work, but it wouldn't do what we intended. A logic error is when the program runs, but doesn't do what the programmer intended. Okay, we're going to more fully expand our solution from last time. So I'm going to have similar things from before. In fact, just pause for 1 second. I'm going to just put some bits and pieces in. Okay, so we've done the first part, asked how tall they are, allowed them to input it. Now, before using an if and else statement, you can go in two directions. There's two possibilities. Well, now we're saying, if we read the problem for a second, either they go on hyperspace mountain if they're 120 centimeters or taller. They can go on Big Thunder Mountain if they're 102 centimeters or taller. Otherwise, they can ride the teacups. So we have three outcomes. To do three outcomes, we're going to use an if and then something called an else if and an else. Think of this. Think of the if, else like this. The if and the else are like the bread of a sandwich. So you always need the if and the else. But you can have as many fillings on the inside. So I could have if, else if, else if, else if, else if, as many as I'd like, although it will get a bit complicated, and else, and that'll still work just fine. So let's kick this off by, oh, and by the way, if you're not too sure about how to write this, remember, you can look at the top right, and I've left in here the link or the official pseudocode guidance on how to write it. So let's go for this. So if, what's the first thing we're testing? Well, the first thing we're testing is height. And this is going to be written just the same as last time. So again, greater than or equal to 120. Well, if that's true, then we do our output. And just pause that for a second to write it. Okay, so that's done here. Now, here's where we're going to do a change. Now we're going to do a new command. We're going to go else, one word, then if, second word. And we need to put the test. Well, the test is to see if they're tall enough for Big Thunder Mountain. So we'll say height is greater than or equal to, and I think it's 102. Then we write this pretty much like an if statement. So we say then, and we do the, again, output. And I'm going to be a little bit lazy, if you can forgive me. I think I'm going to write Big Thunder Mountain as opposed to the whole sentence. Okay, now Remember I said that the if, else if, else if, else is like a sandwich? Well, we've got one bit of bread with the if, we've got one filling with the else if, we have to finish this with an else. So we'll do this down here. Of course, we could have had as many else ifs if we wanted, but actually, because we only needed 3, this works just fine. The else will catch whatever's left. We don't have to do a test this time. We've already said it's either above 120, it's equal to or above 102, but between 102 and 120, or it's anything else, and anything else must be less than 102. So we can just go else and output. Remember, I'm indenting again, and I'm going to be a bit lazy. Hope you can forgive me. I'm just going to write teacups. There we go. And we're not quite finished. We also have to write an end if, and that indicates that the if statement has finished. There we go. Okay guys, so we're on programming conditionals. The idea this time is I want you to read through this problem, have a good look at it, write this problem in your book, exactly like this, and then have your best at solving it. Just pay attention to this, look at the outcomes. There's 1, 2, 3 outcomes. So think an if and else will only give you 2. So think about what you're going to need. You're going to need an input. You're going to need a question to be asked. So the system have to ask the user. The user then inputs the value, and then you look at that value, use your if, else to output the value. Best of luck. Okay, so now we're going to crank it up a notch. We're going to use Boolean operators. And actually, this problem is going to be a lot more sophisticated than some of our previous ones. So let's have a quick read of our problem. Please write an algorithm for a vending machine. Now this is kind of a basic vending machine. It has 2 items. It has a packet of crisps for 50p and an apple for 80p. Now, we are going to take in 2 things from the user. We're going to ask the user how much money they have, and that's going to become important because it's going to determine whether they can afford either of the items, and then tell the user which items are available and ask which item they want. Now, if you think about this, if they have, say, 50p, but they ask for the apple, they can't get the apple. And so if they can't get it, we need to tell them how much money they're short. So that's a couple of different conditions. And we're going to use the AND statement to do that for us. But if they'd have said they've got 60p and they asked for the crisps, we would say, you can afford the crisps. Here's your change, 10p. So let's kick this off. Remember again, this is a conversation between the system and the user. We need to prompt the user to input some information. What information do we need? Well, first of all, we're going to ask, this is going to be a bit crude. Really, it should be, welcome and all that first of all. But realistically, we're a bit short of time. So I'm going to cut to the chase and say, this is a bit brutal. How much money do you have? Now, I want this expressed as an integer. Remember, an integer is a whole number. And I want this in the number of pennies. And I should have specified that. But you can appreciate we're a bit limited for time and space. So we're going to cut to the chase here. The person's going to input that value, so we need a variable to store it. So why don't we store it in money? And remember, if we're assigning a value to a variable, we do the arrow, we point towards it, and then we use the command user input. Now, the next thing I guess we should say is we should talk about what the options are, which are a little bit limited, but never mind. So output, okay, again, I'm not going to ask this very well, but I just need to do enough to communicate the idea to you. So I'm going to literally, we should say something like, would you like an apple or would you like crisps? I'm going to say apple or crisps. Again, I hope you can forgive me for being a little bit lazy here. Now, we're going to ask that question, and now the person's going to have to make their decision. So why don't we say that's their choice? So that's a new variable there. And again, we're going to allow the user to input that decision. So we say user input and then they can decide. Now, think about it. We now need to check. So we need to say if choice is equal to apple. Okay. Now, one of the things I'm actually going to do here to really make it clear, I'm going to put brackets around that. And then I'm going to say, and what's the other thing we need to check? We need to check they have enough money. So we said an apple was 80p. So we need to say, and the variable money is above 80. Now, if we said above 80, ooh, I'm about to make another error again. Do you remember what kind of error this was? So if you look at my problem here, I'm saying they picked the choice apple, fine. And the money is greater than 80. Well, that would nearly always work. Hey, but what if they have exactly 80p? That's not going to work. So I've made a logic error. It doesn't do what I intended. So we need to say greater than or equal to, just like that. And if they're both true, well, that means I can afford it. So I can say output, and then maybe something like what you have apple. This is a bit crude. And it said I had to say how much change. So maybe I can say, what can I say? I can say, let's see if I can actually fit this in here. You have plus, to make the change, if you think about it, it would be money. So the money you had, take away the price of the apple, which will be 80p. Remember, if we do plus to a string, it will stick it on. And then we say change. Right, what's next? Well, the next thing might be that you do a else if. Okay, but what happens if the choice was apple and they didn't have 80 pence? Okay, well, in that case, we'd have to say, I'm not going to write it here, but you could say, if choice is apple and money is less than 80 pence, you can say you don't have the money. And you could expand it that way. Can you see how ands and ors are going to expand your power to express more ideas with even more precision? On here, I want to give you a little test here. So you want to write a program that gives the students the answer to a logic gate question. And the two logic gates we'll be looking at is a OR gate and an AND gate. So first question would be, system prompts the user what type of gate, OR gate or AND gate. You pick it, then it asks you what inputs, what's the first input, what's the second input, and then it can tell you what the output would be. Remember, with an OR gate, if they're both on, so if they're both 1, it'll be output 1, 1, 0, 0, 1. You know what? If you can't remember, you can just easily check it either online, or you can consult your book, or maybe even ask a friend. Best of luck. Give this a good chance. You can really get to use of Boolean operators here.